continue with the effect of pile spacing on the capacity. So, various things needs to be investigated. Actually, quite a bit of research has been done, only the limitation is not much experimental, mostly on numerical modeling, empirical, and to some extent several assumptions have been made, like multi-layered soil has been taken as single layer soil, average properties. So, a lot of simplification has been done, but though we will say limited experimental work, API recommends certain aspects in terms of simplification for design purpose. So, if you are able to maintain the spacing of piles beyond 8 diameter, so if the diameter is 2 meters, make it 16 meter, then probably the effect of interdependency on the response due to load on the other pile is very minimal. You can say we can ignore it. It is not that it is going to be 100% not affected, but to maintain 8 diameter is going to be a big problem. So, if you just go back to this picture, or maybe the simplest picture like this, if I have to maintain 8 diameter distance between this and this, having a pile diameter of say 1.5 to 2 meter, the distance becomes considerably large. So, what will happen is you may not be able to actually have 2 piles in a corner, you actually will have to have a single pile, because if you look at the distance between this pile or this leg to this leg could be around 10 meter, 15 meter, 16 meter. So, what actually have indirectly telling is you can't have a group of pile, you can only have single pile at each leg. If you want to have 16 meter, what will happen is this pile will go this way and this pile will go this way, or you can just have it any direction to make a distance which is practically impossible. So, that is what the conclusion we are trying to make. So, we are not actually going to come to the conclusion that we will work out what is the effect of group and then fix the spacing. We actually fix the spacing and then look at the group, because we are forced to do it. Whereas, in case of onshore, for example, if you go to this type of pile configuration, if you feel that having a group effect is too much, then you have little bit of flexibility, you can make it maybe 3 diameter, 4 diameter, 5 diameter, maybe you can manipulate. Whereas, in terms of offshore structures, manipulation is limited. That is what you need to get in your mind, that we are not going to work out pile spacing and then come back with the design capacity. So, that is something is very much specific to jacket type of structures. So, 8 diameter suggestion means if you are able to maintain spacing like that, maybe we can ignore, but otherwise if you have less than that, then you look at each one of the aspect and look for reduction in the capacity. So far we have already worked out axial capacity, means of skin friction, means of end bearing, and also lateral capacity. 3 things we have already worked out. 3 displacement relationship also we have worked out, basically Tz, Qz and then Py. Now, these also will get degraded, because what happens is the soil in the vicinity is actually overloaded, because the load from another pile is coming, and because of that, that means the pile will deflect more than what you supposed to get if you actually do a calculation based on single pile analysis. So, that means the load deflection characteristics also going to change, that means it is going to degrade. For example, if you have a 10 mm displacement and 100 kilonewton is your capacity, and because of interference from another pile, what will happen, either the capacity will reduce for the 10 mm, or for 100 kilonewton the displacement will be larger, is not it, because the contribution from another one is coming and disturbing it. So, we need to redraw the graph by either multiplying capacity by a reduction factor, or multiplying the displacement by a multiplication factor, which will always be greater than 1. So, we call it T multiplier or the load multiplier. So, either way one will be a value greater than 1, the other one will be value less than 1. So, that is what our interest is, to find out what reduction effect that we are trying to achieve when you make the pile spacing less than 8 diameter. So, that is called the group effects in total, basically you have axial, end bearing and then lateral. So, in here we are just going to look at what methodology available today. Of course, you could best possibly do a experimental study, which will be difficult to do, because a lot of work involved, time involved. You can do a numerical analysis using finite element techniques or other, or you can use simply what is been suggested by various literature based on empirical or So, mostly we are going to use in the industry, we are just trying to use what is available, but in some cases specific to each project you may actually do a study of your own, including either FE analysis or something similar, to arrive at your comfortable level of what has been suggested in the literature, what is specifically for, because the limited projection has been given for industry use. Though a lot of research is there, but directly trying to use it in the design work is very limited. So, that is where you will find some difficulty. So, let us just quickly start with what is the axial capacity effect. So, normally if you look at say 2 piles, the pile is circular section and installed at a specific spacing, say 2 diameter, 3 diameter, and when you apply a combined loading on this, normally when you look at onshore structures, normally you have a pile cap, a combined concrete cap, and you apply the load to the cap and the pile is shared equally. If the pile stiffness is same both of them and the stiffness of the pile cap is almost symmetric, then you will get 50% load on one pile, 50% load on another pile. Now, when this load goes down to the soil and then the soil is loaded, and as I shown in earlier sketch, some part of the soil below the ground is going to be loaded twice. So, basically that, and when you try to fail this soil, some failure pattern will come for each pile and it is going to fail together. If you keep these piles very close, what happens is plastification of the soil within the zone between the 2 piles is going to be very fast compared to the soils outside. So, what happens is we need to find out what is the failure load or ultimate load of this and ultimate load of the combined system, and that ratio is called the group efficiency. So, ultimate load of pile group capacity, how do we evaluate is something that we need to just devise a method, whereas the sum of ultimate capacities of each pile, or if it is same pile capacity multiplied by number of piles, you can do this. Whereas if you have different types of pile, for example in a group you have 1 meter diameter, 2 meter diameter, or different types, different shapes, then you just cumulatively add all the pile capacities, and this gives you an idea that the group efficiency or the efficiency factor will be greater than 1, if you have this pile group is higher, but many times you will find pile group capacity may be smaller. This is what we are looking for, because so basically if you look at some of the pictures, I will just show you before we go further. If you look at this particular picture, you see here one corner I have enlarged for you to understand. So, you have the 2 numbers of piles, this is one pile and this is another pile, isn't it. Now, when you actually try to make a failure of a single pile applying axial load, the failure surface is on the surface of the pile itself, isn't it, because the skin friction between the soil and the pile is trying to shear off. Now, if the pile is so close, almost getting together, when the spacing is so small, the failure may also occur along the periphery of the drawn circle here. So, basically semicircle and then a line joining this pile and this pile. So, they are going to go together. If you have a rigid pile cap at top, the load is just shared equally. So, making sure that the soil becomes part of the pile because it is too close, it is just compressed. So, what happens is the capacity of the group can be calculated, the skin friction between the soil and the pile times the surface area is not anymore 2 circles times the length, it is just going to be the surface that I have drawn here as a dotted line connecting the pile to this pile, and you can see here this area will be taken. So, when the capacity will be smaller, the group capacity will be smaller, as long as you keep this, the distance between this point to this point is less than the half surface area of the pile itself, because when it is become too small, then the capacity of the group will be smaller. But as long as you go larger, the group capacity is going to be definitely larger, because the distance becomes. So, you can see the dependency of the spacing, yes, as long as you just keep away indirectly, instead of going into your analogy of load transfer from one pile to other pile overloading, as long as you can keep it away, the larger the distance, the failure surface is going to be bigger, and then you are getting capacity bigger. So, in terms of single pile capacity, what you normally do is skin friction multiplied by pi d times L. isn't it? That is what we normally do for a single layered soil. For a group, what you are going to do is you are going to calculate the surface area of this, because that is the interface. The only difference is the skin friction between soil and pile is here, whereas in this particular place there is no pile, but it is a soil to soil failure, because the soil between the pile is getting almost similar to the soil. So, maybe slightly lesser skin friction value may also have to be used, because here is a pile to soil, here soil to soil. So, that is basically the idea. The block capacity is calculated as the block surface area multiplied by the length multiplied by, if you have a multiple soil instead of single layer soil, you just simply calculate the same methodology what you are using, calculate the skin friction in each layer and cumulatively add the capacities and so on. So, basically that is the idea behind the ultimate group capacity has to be established by somehow, either the way that I have explained, or you do an experiment, or you do other means of evaluation, and basically the individual capacity also easily calculated by soil engineering methods or by other means. There were several research work done by quite a number of people, basically several empirical formulas do exist, but not specifically for our types of work, basically for onshore structures. So, you see here Labare formula using the spacing between the big group of piles just for onshore industrial type of structures, wherein use small diameter piles. Normally we do not use for even building structures. Now, I think 20 years or 30 years back, the large diameter piles were very rare, because installation methodology was not that much possible, because the hammer was not available. Making such type of pile also very difficult. Those days they used to use 200 mm square concrete piles, 300 mm square concrete piles, precast piles. But now nobody goes for such type of things unless very limited equipment availability. So, you can see here several number of piles together with a big raft on which you will have the structure completely. So, instead of going deeper, instead of going bigger diameter, smaller size, not necessary that they will be circular, they can be square or rectangular piles, concrete, steel, timber, sometimes people have used timber piles. So, many of them, the idea is spread the load and go to a better stratum. So, basically that is the kind of idea. So, when they were looking at the failure surface will be somewhere around here, basically you take the peripheral rectangular surface joining all the pile surfaces. So, you will see that that is the failure surface for calculating the capacity of the group itself. So, the formula proposed by Labare is just little complicated, number of rows, number of piles in another perpendicular direction, and zeta is the angle, d is the diameter of the pile, and s is the center to center spacing between two of the piles. So, basically using this formula, the efficiency of the group can be calculated by using this simple rectangular system. So, number of columns and rows is basically the arrangement of piles. This was used several years back, but nowadays even onshore projects they are not using it, because almost every particular specific area require different type of configuration. This is only possible for such nice rectangular array of piles. The other one proposed by Terazahi and Peck as early as 1960s, you can see here is a reverse capacity formula. The ultimate capacity of the group is equivalent to 1 by n square P1 square. P1 is nothing but your capacity of a individual pile, and Pb is the capacity of the block or the group. So, basically you can calculate using the method I was explaining. You just find out the peripheral area of the pile group multiplied by the soil pile interface friction and times the length will give you the block capacity, and P1 is the conventional axial capacity you calculate by means of skin friction times the length times the surface area, and you resolve this formula to get the ultimate capacity of group, which was proposed by this. So, you can rewrite this equation in terms of 1 plus n P1 by Pb square is 1 by eta square. So, you can just reverse it and you can get the efficiency of the group. So, in terms of offshore systems, what we will look at, how do we calculate the effect of at least 2 pile first, then we can go to 3 and 4, because most of the projects, if you look at the pile configuration, we will have 2 or 3 maximum. Very rarely you will have number of piles more than 3 and 4, which will be very remote situation. So, just look at 2 piles and the contribution of the second pile to the first pile on load capacity reduction or increase in deflection will be looked at. So, the increased deflection of the pile in consideration is basically the original deflection calculated by the single pile load deflection graph multiplied by multiplication factor is basically JUT m or whatever terminology you can give, is nothing but 1 plus alpha v. So, this 1, if alpha v there is no group effect, alpha v will become 0. So, alpha v is always going to be somewhere higher. So, basically you can add and multiply. So, you have 2 things to look at, one is the capacity reduction, the other one is displacement increase in terms of either T jet or Q jet. So, typically if you look at loading on each pile, if they are equal then it is easy to compute, otherwise you have a load of P1 on the first pile and P2 on the second pile, and the contribution of P2 towards a particular location, we do not know where it is, depending on the spacing the location will be different. So, it is going to contribute a vertical displacement increases, because there will be vertical displacement of the pile due to P1, you already have your T jet established for each layer, and for because of P2, because it is too close, there will be a deflection increase on the pile 1 because of P2. So, this is the cross correlation. Suppose if you have 4 number of piles, you see here like the one that we were looking at, you will see a certain portion of the pile soil interaction, basically the soil is subjected to 4 times the loading. So, you will see that that is the concern that we have, which is going to be the evaluation technique. So, basically the pile configuration which we have seen earlier, one of the important thing is the loading, which is also going to contribute. For example, if the loading is going to be exactly along the line of the pile center line, for example, this is pile 1, this is pile 2, if the loading is along this, so the second pile is in actually the shadow area of the pile 1, which is going to be full effect. But if the loading is on the y axis, so that what happens is part of the loading is going to be just getting some influence, whereas is not going to be full effect. If the load is along the y axis, there will be one loading here, another loading here. So, basically the orientation of the pile with respect to loading is another parameter which will actually influence, but then in offshore structures, especially horizontal load, what we are talking about is a horizontal load. Vertical load, of course you will have. So, the load orientation or the orientation of the piles with respect to the parent support structure is also going to be important parameter in terms of evaluation, which we need to take into account. But for the vertical loading, I do not think you need to have much problem. So, in here ZM is nothing but 1 plus alpha v. So, this is the one that we were talking about earlier on, too close a spacing, this is what will happen. If the spacing is kept larger than 3 diameter, so you can see there, but this bulb is keep on increasing. If you go back to the first picture which I was showing, as you go down the bulb size is increasing. So, the deeper you go, you will see that the overlap will be slightly more. So, for 3 pile system, if you look at it, you will see that there is a interface overlap between these 2 piles as well as the other 2 piles, whereas these 2 piles there is not much because it is already very far. So, but if you look at the failure surface as a group, you can see here this is bound by the outer surface, this basically joining the outer 2 piles and this inner pile. So, for a 3 pile group system, if you try to bring this one in here, what will happen if you keep that in the line, you may not actually get the spacing requirement, even if you want to maintain. So, that is why you have to just go out, you make sure that this S is maintained whatever spacing required. Or if you want to keep like that, if you keep the pile here, then this pile have to go this way and this pile have to go downwards. So, if you just draw just for the 2 pile group efficiency, you can see here the efficiency, the spacing ratio is spacing divided by the diameter, and the efficiency basically if you look at 3 diameter, or in fact you can go back to the efficiency of 1, if you just keep it at about 1.6 diameter for axial capacity. So, you are going to get almost not much effect, but if you come less than that, then there will be reduction. So, for example, if you keep 1 diameter spacing, you will have almost 20% is gone. So, that is the indication that you should look for. But normally most of the codes suggest that you keep the diameter the spacing ratio as around 3, not only with respect to axial capacity, but also lateral capacity, because lateral capacity what has been suggested is 8 diameter as a overall spacing. So, if you keep it at 3D, you may actually not get any axial reduction, but you may get large reduction in lateral capacity. That is what the idea. So, this basically how it is calculated. If you go back to this picture, you can calculate this is basically pi d by 2, and there is another pi d by 2 and plus 2s, because s is the spacing of piles. So, simply multiplied by skin friction and multiplied by the length. So, you get a group capacity. Individual capacity is 2 times pi d times L, is not it. So, that is the formula that has been used here, so that you can just find out where we are, and this is basically based on simple assumption of same soil and just uniform calculation. But if you have multiple layer soil and different, so you may get slightly different, but indication is axial capacity is not as vulnerable as what we were thinking. You know, you do not need to go to 8 diameter, you may actually keep it somewhere around 2 or 3 diameter, which is good. Theoretically speaking, your block capacity is going to be okay as long as you keep it beyond 1.6 diameter. So, that is the idea that we need to. If you keep it at 1 diameter, that means it is a touching pile, you know, basically half a diameter here, half a diameter here. The piles are constructed just one next to other. I think most of the time they do it in retaining structures. Sometimes you might have seen piles are constructed one after the other without any gap for retaining structures. So, basically that is the idea.